Hello, everyone. So, I hope that you all are doing well. And in a previous few videos, we covered about uh, abstract data structures and as well as some implementations in ASP.NET like list, linked list, array, and stack, queue. Now we will start with some advanced data structures in today's video. And the advanced data structures are essentials in diverse computer science and software engineering applications, where data management, efficient search, and algorithm optimization are the key concerns. So they provide the foundation for solving complex problems and improving the performance of a software system in areas such as database, operating systems, networks, and many others. So the understanding when and how to apply these frameworks is a crucial and designing efficient algorithms and data management system. So advanced data structures mainly deal with the management issues, okay, how to handle the large amount of data, how to optimize the things and all this thing. So that's why they are complex and specialized data organizations that provides efficient method for storing and manipulating the data across variety of computational tasks. So these frameworks are nothing but a design for the optimizations and standardizations for the data related functionalities such as retrieval, insertion, updation, deletion, manipulations. Okay, and generally have applications in a wide variety of scenarios. So basically below are some examples of advanced data structures. So tree data structures are includes binary trees, AVL trees, red black trees, B trees and others. Then heap data structures are there like binary heaps and Fibonacci heaps and binomial heaps, hashings, again, hash tables, hash functions. So these are some advanced data structures we will understand in today's video. Let's go ahead. Now let's start with the heap data structure. So what exactly the heap? Heap data structures refers to the specialized data structure that is used to store and manage the elements in such a way that allows the highest priority elements to be easily accessed and removed. So, in a heap data structure, there is always a priority on extra value has been added. Okay. And in a C hash, binary heap is often implemented using the class called as a priority queue, and which is available in a system.collections.generic library. Now, again, while we are discussing about the heap data structure, so implementing there are the two types of heaps: max heap and minimum heap or min heap in a C hash. So it can be accomplished using a class like a priority queue, and as mentioned previously, also, however, the that be the default priority queue creates minimum heap, and uh, if you want the max heap, minimum heap, it means the data will be fetched uh, with the minimum priority first, and max heap nothing but a, if you want to fetch the data with the highest priority order, then there will be a max heap. So let's go ahead with the priority queue because the implementation is by means of a priority queue in a ASP.NET. So priority queue represents a collection of atoms that have value and its priority. On a DQ, the atom with the lowest priority is removed. So basically, by default behavior of a queue is with the lowest priority, the value has been removed. Now, for that, implementation class is priority queue with the two parameters. First one is the T element. It specifies the type of element in the queue, and the tree priority is nothing but specifies the type of a priority associated with the enqueued elements. So it's implemented in the form of an array back, and basically it's a minimum heap. The initial, whenever you create a priority queue, it follows the min heap. Each element in a EQ'd is EQ'd with the associated with the priority, and that determines the DQ order. Elements with the lowest priority are DQ'd first, and note that the type does not guarantee first in, first out semantics for the elements of a equal priority. Okay, now let's go ahead with the priority queue. It's a type of a data structure, holds a collection of elements of a sum type, and each element is in queued with the associated priority. Okay, and that determines the order. Lowest priority are dequeued first. Now, even though we have a queue in the name priority queue, but it does not guarantee that the order of the element dequeued will be the first in, first out, and for the equal priority. Now, this is the example of a priority queue. So, if you can see priority queue having the two values in queue, first one is the value and second one is the priority. And try to requeue priority queue, it's in iterating by means of a while loop, and it's fetching the values with the lowest priority. And there is a T priority is the type of a priority, and when choosing a priority type, make sure that it has a default comparator. For basically, for example, the usage of a priority queue accept two types of classes. Okay, first one is the T element, and second one is the T priority. Now, if you are using T priority on the basis of a different data structure, then make sure that a default comparer will be added. Okay, and then it get implemented because it get compared which is the lowest priority, and then based on that the element will get dequeued, right? Now one more class is available in ASP.NET with the unordered atom collection. Now what exactly it is? Now this is the priority queue dot unordered atom collection class. Now what exactly it is and what is the use of it? The characteristics is nothing but unordered. The atoms are not guaranteed to be in any particular order, including priority order. Now, if you are asking, like, okay, it's not following the queue order, it's not following the priority order, then what is the use of it? So, this is a kind of a snapshot. So, consider you don't want to fetch the elements of a priority queue on the basis of a priority. You just want to visit the element, you just want to view the element. So this particular class is for that. It's not a ordered form. Okay, it's an unordered atom list, unordered atom collection. So it's a read only. It's a snapshot and it's a read only. And you cannot add or remove the elements through this collection. And it reflects the state of a priority queue at the time of a enumeration. So whenever you are iterating through it, it only iterate and it's not follow the particular order. So you can effectively interact with the elements of a priority queue in a scenario where the order is not critical, but the access of the all element is necessary. Now, when you will use these things, if you want only the snapshot of a priority queue and you just want to visit what are the elements are there in this particular class, then you can go ahead with it because it's not needed all the time, right? You just want to check what elements are there. If you want to fetch the elements in a particular order, then there is a requirement of a priority in all these things. But in this case, it's not required. So they gave a special class for it to fetch the data, to view the snapshot. Now the next data structure is a tree. Obviously, tree is a hierarchical relationship between the elements. Okay, there is a root, there are the left child, right child, and based on the which type of a tree you are using, the elements will get inserted. Now, what is the advantage? Um, Directly, we are not using advanced data structures in medium level products. But if your product having huge amount of data and frequently there is a searching operations are happening, insertion operations are happening. So in these kinds of a product development, you have to use the specified data structure rather than the list, because uh, fetching quickly is really important when your data is huge. So obviously tree data structure is really useful. It will just half the data, cut half your data set. Consider you are storing the data in the form of a binary tree. So obviously you compare that particular element. If you want to search the 25, consider in this case. So the half of the binary tree will get removed. We don't want to visit this particular left binary tree. We have to search only right, because the 25 is greater than 21. So the data set will get half and the searching technique will be the faster. So if you have a huge amount of data and you are doing frequently searching and fetching things, then obviously these advanced data structures are really useful. So trees are the type of a data structure used to represent the hierarchical relationship between the elements. And tree are widely used in a programming for various purpose. And Chash offers the flexibility to work with tree data structures and implementation as binary tree and binary search tree. So I visited most of the applications, but rarely these kind of a data structures are used. So I just request you, wherever you want, try to use it and check the performance after that. Next one is the graph. Again, rarely used. It based scenario based. If your product is related to the particular requirement and it's want kind of a particular performance criteria, then these kind of a data structures are important, because again implementation, designing and development is little bit complex as compared to the normal data structures. So graphs are the data structures characterized by the nodes and edges joining the nodes, nothing but edges. Usually using the notation G is equal to VM, where V represents the set of the nodes and E represents the set of the edges. So in this particular image, you can see there are the vertices. You can see 0, 1, 2, 3, 4, and there are the edges. So V is nothing but a collection or a group of vertices, and E is nothing but a collection of or group of edges. So in the programming language, it's represented adjacent matrices. For example, A of ing is equal to K. In this, ing is nothing but a node and K is nothing but a weight K, and adjacent nothing but that particular weight of that ing. And adjacent lists are also used for their representations. So if you want about graphs more, you can go ahead. It is not actually implemented in ASP.NET. So let's go ahead. Now hashing data structures. Okay. Now this is one more important data structure, and which is well implemented in a ASP.NET with the form of a dictionaries, key values, and all these sets and all. So hashing is a fundamental process in a computer science which involves the transforming input data into fixed size value, and often that particular code is called as a hash. Now using particular function. Now there are some inputs A, B, C, D. We convert that function into the common sized values by means of a hash function. So one function is responsible for converting the values of a entered data into particular common or fixed size values. Now the main feature of a hash function is that they produce the fixed size output regardless of size of an input item. So it doesn't matter that your first input is an array, second input is a collection, third input is this. But what they do, they convert that input into the fixed size in. Okay, that function which is responsible for converting the input into the fixed size output, then that function is called as a hash function. So this hash is used to represent the original input in a compact way. Sometimes what happens when you are inserting particular data in a data structure, the length of the data structure matters, or some memory issues are there. So in this case, what we do, we use the pointers and we use the references that, okay, so this input is available at this particular location. But who is going to tell the address? This hash functions are responsible, or hash values or tables are responsible for that. That this is the key and this is the value. Like this, it gets stored. Now, the biggest advantage of using hashing data structure is that they allows you to store the data and search it in a constant time, and that is nothing but a 0 of 1. Again, searching is little bit faster in a hash table because you just have to find out where it get located. Now, what exactly the hash table is? It is a data structure implemented in a ASP.NET framework in two ways. First one is a normal um, simple hash table in the system.collection as a generic data structure dictionary in the system.collection generic namespace. It is recommended to use the dictionary instead of hash table because again it's a generic one. The working principle of a hash table and dictionary is that construct a hash that is indexed to an array usually used polynomials, and searching in a hash table and dictionary has a complexity of a time 0 of 1. It's search very fastly. If you observe, this is the best case scenario if you are aware about the complexity in a first video. So obviously it has a very good searching what cases. So accessing a hash table value, if you can see here, cat is there. It's located to the index 2. It goes to that location and then it's fetch the actual data. So searching will be really fast. So the element and the data where it get actually stored, it's stored in the form of key and values. So they go to that particular value, they find out the value, and you don't need to compare like in a array or in the linked list. What we do, we find out the element, we compare. Okay, this is the one, no. This is the one, no. This is the one, no. Then find out. Okay, one compared, equal found, and then fetch. But in this scenario, the searching is little bit faster. The hash is nothing but basically made up of a three components. Okay, if you can see, there is a key. First one is the key, and the key is nothing but a value you want to store for store or fetch from the hash data structure. So if you can see, here is the 2 is the key. Okay, and it is used as the input to the hash function to calculate the index where the associated value will be stored or looked up. So 2 we are passing, sorry, here a cat is a key, sorry, it's a key. Then we are passing that cat key to the hash function. Hash function accept that input and then find out the output is nothing but a 2. Okay, output is 2. Then it go to the related location and then it find out the data. Now hash function is nothing but a mathematical formula or algorithm that transform the key into the hash value. So cat is transformed to the 2 by using the hash function, and that value will get searched in a hash table. So this 0, 1, 2, 3 is nothing but a hash table, and hash table is the data structure that stores the value associated with the key. So key is a cat, value is a 2, that's stored in a hash table, and hash table is nothing but a reference given to the actual date. So when you want to store or look up a value, the hash function is used to determine which list of a hash table the value should be stored or looked up. So in this way, actually, the hashing technique overall or hash table works. Now, hash table is a collection that stores the key value pairs and is a part of a system.collection namespace. Hash table in a C hash is a key value pair and uses the hash based structure to store, uh, provide fast lookup. And it uses the get hash code method to determine the bucket for storing entries and handles the collision through the separate chaining. So here in this example, if you can see that this is the key, this is the value. Okay. Now key will be passed to the function. It will generate the value. Generated value will be searched in a hash table. Okay. By using the hash function, okay, it's that value will be searched in a hash table, and then the related value get, where is it? Delete, clear all drawings. Huh. So in this way, the related located data will get fetched in a very quick manner. So I hope this hashing technique or hash table is little bit clear to you. Now, this is the example, hash table. Again, you can use the dictionary. So add one, and all the values has been added, and when we are fetching it, we can finding in the contains key is available or not. So we are fetching the key and this value is available, then the things are happened. So non-generic, the hash table is a non-generic class available, and it stores the key and value as an object type. And it's often recommended to use the dictionary, okay, key and value, which is generic equivalent available in a generic namespace. By default, hash table is a not thread safe. You can make it thread safe by using the hash table and synchronized method. Or you can use the concurrent package, concurrent dictionary for multi-threading scenarios. Although effective, the non-generic hash table is least commonly used in the favor of a generic dictionary. So it's mentioned that, okay, refer the dictionary class instead of a hash table class. Now, what are the applications? So wherever you want the quick searching and faster fetching requirements of a data, then at that time hash tables or hashing data structures are really useful. So fast data lookup, then indexing the database, caching, unique data representation, handling the large data set in a search algorithm. So load balancing, data duplication, implementing sets. So these things, again, there are key and value data structures are available. To implement that kind of a data structure, you can go ahead with the hashing data structure. So hash tables are versatile data structure and used in a many application that requires these kinds of application, these kinds of requirements like faster fetching, huge amount of data is there. You want to balance the things, then obviously it is useful. So hashing tables, fast retrieval of a record, especially in a large database. Caching, how it is useful in a caching. Hash tables are commonly used to implement the caches, where the key is unique identifier for the cached data and the value is nothing but your cached content. So what is the benefit? Caching using a hash table will allows you to quick lookups for the frequently accessed and reducing the need of a recompute or refetch the data. Okay, because it's temporary, it is stored in your hashing data structure, so you can fetch it from. Next is nothing but a routing tables in a network. Routers uses the hash table to store the routing information. Okay, so there are the different elements, there are the different devices are attached, and obviously these things maintained in the form of a hashing. So efficient routing decisions enable fast packet forwarding and across networks. So these are some benefits, applications of hash tables or a dictionary. So we will cover dictionary or whatever the pending collection classes in next few videos. So all about the data structure and advanced data structure, what exactly the conclusion is. Like we learned about the three types of complex data structures like binary, heap, and hashing. So these concepts are very commonly used in a web applications where there is a need to deal with a large amount of data, and in a scenarios like common problems like optimization, standardization that can be easily solved by these data structure. In addition to these, there are several other types of a data structures that you may know, but these three are already a starting point for the familiarizing yourself with the this particular data structure subject. So if you want some in detail advanced things, you can visit related data structures series are there, basic tutorials are there. Sometimes important to remember is that C hash has a many features for working with the data structure, such as a hash table class, for example. So, so consider using the native ASP.NET Core structures whenever possible. Some data structures are implemented internally in ASP.NET, and some are provided in the form of a classes and enumerators and in different types of interfaces. So you can go ahead and try to use the different data structures when you are developing a particular product. So whenever you try to plan any kind of a product, just write an algorithm, then you can create a flow chart. It's a basic development scenario, but still we forget to do it. Okay, try to decide which kind of a data structure will be beneficial for which module and then go ahead with the actual development. So here we done with the data structures and algorithms. Now in the next video, we will try to cover the composite data types and some pending classes of a collection framework. Because in ASP.NET, we are not using the abstract data structures. We have a implementations of these data structures, okay? And how it get implemented in ASP.NET, how you can utilize these things, what are the different composite data types, and what are the different pending collection classes. These two things will get covered under this section. So I hope you will understood the concepts we covered, and if you have any questions, we will discuss the things in a next Q&A session. Take care. Bye-bye.